All right, today we're going to be talking about function families. Families of function. Who knew equations belong to a cute little family? And this might just look like a letter code to you, but what this means is mathematics. Functions 1.1. So this code is readable. Given an equation or a graph that defines a function, determine the function type. That's what we're talking about today. So number one in Bellwork was to write this standard. Number two is the definition of function family. Functions that share the same characteristics. There's lots of different function families. Cubic functions, rational functions, square root functions, quadratic functions. That's what we're going to talk about with factoring. Linear functions, that's your rise over run slope. Absolute value. Groups of equations that are similar. We call them families. The parent function is the most basic function in the family. So today we're going to go through 4 different parent functions, and then we'll look at how to compare other functions in the family to the parent function. So take one of these and pass it back. Everybody gets one. Take one and pass it back. Oh, they stopped with you. Your name is, and I'm not going to Are there any extra handouts in here?
Oh, I hate these. I hate them.
Oh, shit, Raise your hand if you didn't get one. This guy. All right, there's really technically infinite function families out there in the world. This handout covers 4 different function families. The constant, which will be covered in this first box. The linear, which is the second box. Absolute value and quadratic. So these are the 4 that this handout will cover. There's more. Can you read that? The constant function family is a horizontal line. It's a flat line. It has no slope. To be honest with you, this is the least interesting function family out there. So we talk about it very little. We cover it right here. There's like 2 questions in your textbook about it, and then we move on. An example of a no slope line would be y equals 1. Nope, I'm going to fill out the table. So for this table, we're going to plug in -2, -1, 0, 1, 2 for x. And actually, there is nowhere to plug in for x. All of the y values will always be 1 in the constant. And so that's why it comes out to be a horizontal line. A horizontal no slope line. The most boring of all the function families. I don't like it. I don't like to talk about it. It doesn't even have a slope. 0. All right, domain. I wanted to remind you about what this word domain means. It's a set of x values, true for a function. So tiny. I'm going to make this better the rest of the day so I can zoom better. And range is a set of y values. You probably didn't discuss domain and range a whole lot in geometry, but it was discussed in Algebra 1. So we have to think back over a year ago. The domain for this particular function is it goes from negative infinity to infinity. So when I think about the x-axis, when I think about when this line ends, and this is something you do talk about a lot in geometry, there's arrows on both sides. The line goes forever. So when I describe the set of x values true for this function, it ends up being infinity. This is called interval notation, and this means the x values go all the way from negative infinity up to infinity. For range, call it R. It's just 1. The y value always equals 1. It's constant. That's why it's called a constant function family. Y is 1 all the way through. That's the range. Range is y values. So it's consistently boring, flat line, y equals 1. Now this guy can move up and down. Okay, it could be y equals 10. It could be y equals -23. It could be y equals -1 million. It moves up and down, and that's pretty much it. The linear function family. This one will definitely have, well, technically the constant goes into the linear function family, and there's a little overlap there. But we're going to go ahead and talk about this equation, y equals x. This is the parent function, y equals x. Or you could see it as 1 over 1x with the invisible 1 in here. If I wanted to write it, it would be 1 over 1. And that would represent the slope or the rise over run. Yeah. So it does have a slope, yeah. So we're going to fill out a table. We're going to plug in x is negative 2, y, x is negative 1, x is 0, x is 1, x is 2. Mm-hmm. Yeah, the new books are over here on this side of the room. After you rip out, you can put them in the closet. Alright, so if y equals x, if x is negative 2, y is negative 2. If x is negative 1, y is negative 1. They're the same. Y is x. Y equals x. So now we're going to plot these points. These are coordinates. Negative 2, negative 2. Right down there. Negative 1, negative 1. Right down there. 0, 0. Right at the origin. Right there. 1, 1. 2, 2. That's the most basic linear function there is. Now, this function could be translated up and down. It can shift up and down. It can go flatter. It can go steeper. It can flip. You can reflect it. So we will be, as far as the function family goes, this is the parent. And if you move it up or down or flip it or anything like that, that's like the child of the function family. It's a transformation of the parent. So this is the most basic linear function there is. The domain runs from negative infinity to infinity because it has arrows. It never stops. And so does the range. Negative infinity to infinity. And practice your sideways 8s there for your infinity signs. It goes left and right forever. It goes up and down forever. There's a little reminder, like Desmond's been saying, we're thinking slope, rise over run. Or if you even want to write this, if you have extra room, y equals mx plus b, that's the linear function family. There's other forms of that, ax plus by plus equals c, but that's the one we like the best. So far, so good on our function families. Let's hit absolute value. Are you ready? All right, very similar to linear. Instead of y equals x, it's y equals the absolute value of x. So it's the same thing, but we have bars in it. So same table, negative 2, negative 1, 0, 1, 2. Yes, but this time we're plugging into these absolute value bars, and absolute value refers to distance. It makes things positive that are negative. So, sorry this is so squished in here, but I'm going to think, what is the absolute value of negative 2? And I'm going to write it as positive 2. And my first ordered pair is negative 2, positive 2, instead of like the linear was negative, negative. So that's actually up here, which is different than the linear is down there. Positive stays positive. And we still have a point at the origin, 0, 0. The absolute value of positive 1 is positive 1. And the absolute value of positive 2 is positive 2. So this is a V shape. Yeah, this is a V shape. If you ever encounter a V-shaped graph, you got to think, hey, that belongs to the absolute value function family. You're thinking of an equation that has absolute value bars. It's the bars that make the V shape. So the domain is still negative infinity to infinity, but the range is more complicated. Range is y value. And so the y values are positive here. So how could I indicate that? I'm going to go with the range goes from 0 to infinity. This is called interval notation, and it has a bracket on purpose. This means it's starting at 0, and it runs up to infinity because the arrows only point up. We don't have a down arrow this time. So our y values are not from negative to positive. 0 is the lowest. Now, you can transform this parent function, and we could drop the V shape, down 8. If I put a -8 at the end of this, it would translate it vertically down 8. And if that was the case, then there would be a -8 in the bracket. So just because it says 0 now, remember this is the parent function. It's the most basic. We can move this V shape up and down. We can move it left and right by adding certain numbers in here. We can flip it and reflect it. We can even stretch it out and make it wide or skinny. So it can change quite a bit. This is the parent function, the most basic. In the closet. And lastly, the quadratic. Y equals x squared. Same table, -2, -1, 0, 1, 2. Alright, so now we're plugging x into this equation, y equals x squared. So -2 squared is a +4. A negative times a negative is a positive. So I have an ordered pair at -2, 4. -1 squared is 1, so -1, 1. 0 squared is 0. Sorry if I'm going too fast. 2 squared is 4. So we're squaring x in the parent quadratic function. So -2, 4 is way up there. Yes, we're going to describe this as a U shape. And it should have a curved top or bottom. It should not look sharp. Sharp is absolute value. Curvy is U-shape. To be honest, the technical word is parabola, which is fun to say parabola. But. All right, and the domain and range is very similar. Domain is all real numbers. In the range, we're going to do that hard bracket again. 0 to infinity. And these are the parents. So they don't show any transformations, but we could take this parabola and we could do a lot of things to it. Move it up and down, left and right, reflect it over. Yeah. I'll take it for you. Well, we can kind of leave them around because everyone's going to see them all day. All right, so we're going to now open our books to page 6, was it? No, page 13. And we're going to now try to answer some questions using this handout. You can also use the examples in your book. Yeah.
Page 6, you said?
Page 13, 1 through 6. Actually, Rocco, you pull out one of these and hand it to me. Binders are good to go. I have your bathroom passes ready. There are 3 hole punch. Every student gets 3. When you go to the bathroom, you fill it out, you hand it to me. They are numbered 1, 2, 3. After you turn in your 3rd one, I'll do a call home and just say, hey, heads up, your student is using the bathroom in math class frequently, and just so your parents know. I've talked to parents before, and they are honestly really surprised when they find out about the frequent bathroom users. They're like, what? Are you kidding me? And I'm like, yep, algebra 2, they're leaving every day. So this is really a method for me to document and communicate with your parents. If you're using your class time wisely, you get 3 per quarter. If you do not use them, you turn them in for extra credit. So that is the other thing. I'm like, man, there are so many students who come in and they're managing their time to focus on classwork. How do I acknowledge that? So you get extra credit if you're one of the students who isn't leaving the room. Each one is worth extra credit at the end.
Who's his name?
Yeah. Yeah, just do that kind of question.
4, 5, and 6. Then we can communicate your guardian. Did you go? Yeah. Everybody get his bathroom back. All right, put this in your binder. Put it right behind your answer. More sample. Let's take a look. How are we going to use this handout to answer these questions? Holy cow. There we go. All right, here's page 13. Mine's a little blurry. Maybe I'll make it better for you. Yeah. So it says identify which function family. So you're going to say, all right, which one of these does it look like from the handout? And then you're going to compare it. And I'm going to give you a lot of details as we go through it, but you're really just supposed to look at it to the best of your ability. So yeah, number one makes a V shape. So I'm going to think about that. So I'm going to look at the function family handout. Which family looked V-shaped? So I can go ahead and identify the function family just by the visual. V-shape is absolute value. All right, so that was the first set of directions. In the textbook, you really have to read the directions because it builds. It's not just one thing, it's usually several things. So first set, check. Second set, compare the graph of f to the its parent function. So how does this one look different? Well, I can visualize the parent function because I've drawn it so many times. You guys are just getting into this. So if you want to put the parent function, remember it goes to the origin. So this is the parent function way up here. So Flynn, tell me one way this picture looks different from the parent function that we did. It's below the x-axis. Well said, it's bigger, it's below the x-axis. So there's so many, and I haven't given you the vocab yet for it, but I think you've heard this before. I'm going to say it's translated down. And in Winter's words, that would be below the x-axis, which is a great visual description. Now, I actually know exactly how many it's translated down because I can count from this vertex down to this one. It's down 1, 2, 3, 4, 5, 6, 7, 8. It's down 8 units. So you can say down 8 units or you could say negative 8 units. It's also over, right? Which direction is it over? Is it over left or is it over right? It's also left. I'm going to use that word translate. I actually know exactly how far left it is. It's left 2 because the parent function's right at the origin. And this one is shifted 2 units over. So I'm going to say left 2 units. Or I could have said translated negative 2 units horizontally. And translations are described in lots of different ways. Now, the bigger idea is interesting. There is something bigger about this. The parent function had a perfect slope. The parent function actually goes up 1 over 1 on the sides. And that's an observation that you probably wouldn't make without a teacher stepping in and pointing out. So the parent function from the vertex goes up 1 over 1, up 1 over 1, up 1 over 1. Now, Flynn, what's the slope of this one? Yeah, can you identify the rise over run on that right branch of that V? Just the opposite. It's up 2 over 1, up 2 over 1, up 2 over 1. So this one, the branch has a slope of 2 over 1. It's steeper. That's actually called a vertical stretch when something is steeper. And I can point out for you exactly where in the equation it says steeper. That 2 in front of the absolute value is what has made it steeper. The minus 8 at the end of the equation is what shifted it down. And the plus 2 in the bars is actually what shifted it left.
We have that left.
Thank you. So you guys are trying this on all 6 of these, okay? You have legitimate homework. You have an assignment. Read them. Try to identify the changes from the parent function. That one you just have to write the family. You don't have to identify the table. Very good job.